What's up everybody, and welcome to part 3 of my coding a decision tree classifier from scratch video series. In the previous video we built our first two helper functions, and in this video we're going to build this function, potential splits. So let's create another subheading for that, and let's write potential splits, and let's also call the function get potential splits. And here we pass in our data, which is a 2D numpy array, and then the function should return all the potential splits. And this potential splits variable is going to be a dictionary, and the keys for those dictionary will be the indices of the columns. So let's have a look at our training data frame again. So then, for example, the pattern width will have the index 3 because it is the fourth column. So the index will be 0, 1, 2, 3. So the key of the pattern width will be 3, and then the value for that would be a list that contains all the potential splits. So for example 2.5, 2.7, and so on. So this is the kind of dictionary that we want to build with this function, and to populate it we obviously have to iterate over all those columns, and therefore we have to know how many columns there actually are, and we can do that by using the shape attribute of our data. And this returns a tuple where the first number is the number of rows that we have in our data, and the second number is the number of columns that we have. And since we don't need the number of rows, we're going to write underscore for that, and the second number we're going to store in a variable called n columns. And now to iterate over the columns, we simply write for column index in range n columns minus 1. And the minus 1 is because we want to exclude this last column, which is the label. And then for each column we're going to create one entry in our potential splits dictionary. So we're going to say potential splits brackets column index, and the entry that we're going to create is an empty list, to which we then want to append our potential splits that we are about to determine. So as you may remember from the videos where we talked about the theory behind this algorithm, the general idea was simply to consider all the values that lie exactly in the middle between two dots as potential splits. So to get those potential splits, we obviously have to get first all the values for that particular feature or column, and we do that by writing values equals data brackets and then colon to get the values from all the rows, and then we only want to have that particular column. And from those values, or let's just quickly print those values in case the column index is 3. So we're going to look at the values from the pattern width, and they look like this. So those are all the values from the pattern width. And now we obviously only need the unique values from this column, so we're going to say unique values equals numpy unique values. And let's also print those unique values for the pattern width, and that's what they look like. And the good thing is that those values are already sorted. So first there's 0.1, then 0.2, 0.3, and so on. And now to calculate those potential splits, what we're going to do is simply we're going to iterate over this unique values array, and then we're going to take the respective element, add the previous element to that, and then we would divide the sum by 2 to get the value that lies exactly in the middle of those two dots. And that's then our potential split. So we are again creating a for loop, and since we want to access 2 elements in each iteration of the loop, we're going to use this range approach again. So we're going to say for index in range of the length of the unique values. And here we're going to skip the first element by saying if index is not equal to 0. And now we're going to say the current value is equal to the unique values brackets index, and then the previous value is equal to unique values brackets index minus 1. And that's also the reason why we skip the first element, because the first element doesn't have a previous value. And in fact, this index then would be minus 1, so we would access this last element, which doesn't make sense. And now to calculate our potential split, we're going to simply say current value plus previous value, and we divide then the sum by 2. And that's our potential split. And that potential split we're going to then simply append to that list that we created at the beginning of this for loop. So we're going to say potential splits, which is our dictionary. Then we're going to access this this list by saying column index, and then we're going to append to this list our potential split. And this is our get potential splits function. So let's copy it and then paste it into the function, into the definition of the function. And now let's see if it works. So we're going to say get potential splits, and we pass in our training data and make sure that we pass in the numpy 2D array. And it looks like that the keys are indices and the values are rows that contain numbers for the potential splits. So let's store this dictionary into a variable called potential splits. And now let's check if those potential splits actually make any sense. And therefore, we're going to create a scatterplot with the Seaborn library, and we're going to use the lmplot function. And here the data that we pass in is again the training data, and the x is our pedal width, and the y is our pedal length. So let's have a look. And now, since we don't want such a line of best fit, we're going to set the fit rec argument to false. And now we would also like to see what species each particular dot is. That's why we're going to use the u argument, and we pass in our label. And this now is the plot that we've used extensively in the previous video series, which was called What is Machine Learning? So now let's just make this plot a little bit bigger by saying size is 6 and aspect is equal to 1.5. So the plot should be 1.5 as wide as it is high. And this now is our scatter plot. So, and now we want to plot our potential splits, which then are represented by vertical lines. So we're going to use the matplot function vlines, which stands for vertical lines. And here the x argument can take in a list of values where all those vertical lines should be plotted. So in our case, that's the potential splits, our potential splits dictionary with the index of 3 to get only the potential splits for the pedal width. And then those vertical lines should go from y min, which is 1, to y max, which is 7. So now we should see vertical lines in the middle between two dots. So let's see if that's the case. And it looks like all those lines are exactly in the middle between two dots. So now let's also check the potential splits for the petal length. So let's comment out this line and let's write p.3 lines this time, so horizontal lines. And here the y takes in our potential splits dictionary with the key of 2, and that's because the petal length is the third column. And now those horizontal lines should go from x min, which is 0, to x max, which is 2.5. And let's run this. And as it looks like, those lines are also exactly in the middle between two dots. So this function seems to be working properly, and this concludes this video. And in the next video, on the upcoming video, we're going to build those last two helper functions. So thanks for watching, and hopefully I will see you in the next video.